Buried deep beneath the layers of rock and sediment that have guarded Earth's secrets for billions of years, lies the remnants of a civilization so advanced, so utterly forgotten, that its very existence could shatter everything we know about our place in the universe. What if, long before the thunderous footsteps of dinosaurs echoed across vast prehistoric landscapes, intelligent beings earthborn, not from distant stars-built cities, harnessed energies we can scarcely comprehend, and then vanished without a trace? What if their downfall was not a cataclysmic asteroid or volcanic fury, but something far more insidious, a self-inflicted wound from their own ingenuity? And what if the clues to their story are not lost forever but hidden in plain sight, waiting for us to uncover them? This is the enigma that haunts the quiet corners of scientific inquiry, a question without an easy answer, one that pulls you deeper into the abyss of possibility, refusing to let go until you confront the unthinkable. Are we truly the first intelligent civilization on this planet, or merely the latest in a cycle of rise and fall that stretches back into the unimaginable depths of time? Let us step back for a moment and consider the weight of that question. Earth is an ancient world, formed approximately 4.5 billion years ago from the swirling chaos of cosmic dust and gas. For most of that immense timeline, life existed in forms we would barely recognize: simple microbes, bacterial mats carpeting shallow seas, organisms that thrived in an atmosphere devoid of the oxygen we breathe today. Yet, within this vast expanse of deep time, there are gaps, enormous voids in our understanding where anything could have happened. Scientists estimate that complex multicellular life exploded onto the scene during the Cambrian period, around 541 million years ago. But before that, the Precambrian eons stretch back nearly 4 billion years, a shadowy realm where the fossil record is sparse, fragmented, and often misleading. It is in these forgotten epochs that the Silurian Hypothesis dares to pose its provocative challenge. Could an industrial civilization have risen and fallen millions, or even billions, of years ago, leaving behind evidence so subtle that modern science has overlooked it? The Silurian Hypothesis, first proposed in a groundbreaking paper published in 2018 by NASA climate scientist Gavin Schmidt and astrophysicist Adam Frank, is not a wild claim of ancient aliens or lost continents. Instead, it is a rigorous thought experiment designed to test the limits of our detection capabilities. Named after a fictional reptilian race from the television show Doctor Who, creatures who supposedly ruled Earth before humanity, it asks a simple yet profound question. If an advanced society existed tens or hundreds of millions of years ago, would we even be able to find proof of it today? Recent updates in 2025 have reignited interest in this idea. For instance, a June article in Science Focus magazine explores how the hypothesis challenges our assumptions about Earth's history, suggesting that traces of such a civilization might manifest as anomalous chemical signatures in ancient rock layers. Similarly, a January piece from IFL Science delves into whether we could detect remnants of industrial activity from a pre-human era, emphasizing that Earth's relentless geological processes, erosion, plate tectonics, and subduction act like a cosmic eraser, recycling the planet's surface and burying or destroying evidence over eons. In a July article from New Space Economy, the hypothesis is framed as a lens for understanding not just our past, but potential futures on other worlds, proposing that intelligent life might be more common in the deep past than we realize. Even the BBC's Crowd Science programme in August 2025 dedicated an episode to unpacking the Silurian idea, discussing how rapid abiogenesis, the emergence of life, could mean multiple intelligent species have arisen on Earth alone. A Liebert Publishers study from 2025 adds weight, arguing that life forms quickly on Earth-like planets, implying that a civilization could have emerged as early as the Carboniferous period, 350 million years ago, without leaving detectable records. This is not fringe speculation. It is grounded in peer-reviewed science, yet it opens the door to mysteries that border on the extraordinary. Consider the out-of-place artifacts, or OOPArts, those enigmatic objects that seem to defy chronological logic. These are not mere curiosities. They are potential windows into a hidden history. Take the Nampa figurine, a small clay doll discovered in Nampa, Idaho, during well drilling in the late 19th century. Initially dated to rock layers approximately 2 million years old, predating not just dinosaurs but the very emergence of hominids, it sparked debates about ancient craftsmanship, though later assessments suggest it might be a 19th century Native American artifact or even a hoax. Its discovery raises questions about how such items end up in seemingly impossible strata. Similarly, the Malachite Man, thought to hail from the early Cretaceous period over 100 million years ago, was initially hailed as evidence of human-like beings coexisting with dinosaurs. Re-examinations revealed it as a post-Columbian burial, but the intrigue persists. The Wolfsegg iron, a roughly cubic piece of metal found in tertiary-era coal deposits tens of millions of years old, was once believed to be an ancient meteorite or artifact, though now attributed to early mining operations. From ancient origins, a comprehensive list of 17 such OOPArts includes items like the Antikythera mechanism, an ancient Greek analog computer far ahead of its time, and the Baghdad battery, potentially an early electrochemical device. A 2021 article from the site details OOPArts found in coal and stone, such as gold chains embedded in Carboniferous lumps dated to over 300 million years old, and iron pots in Oklahoma coal seams from the same era. These discoveries, while often explained as natural formations or misinterpretations, fuel theories of advanced prehistoric societies. A 2017 piece from Ancient Origins recounts the 130-million-year-old human fossil heist, where a purported ancient skeleton challenged evolutionary timelines, only to be debunked amid controversy. As of 2025, Swiss Cognitive reports on artificial intelligence revolutionizing archaeology, with AI uncovering 303 new geoglyphs near the Nazca lines in Peru, massive earthworks dating back to 200 before Common Era, nearly doubling the known count. These figures, visible only from above, have long been theorized as astronomical markers or ritual sites, but some fringe ideas link them to ancient astronauts or lost technologies. This brings us to the ancient astronauts theory, a captivating blend of myth and speculation that posits extraterrestrial visitors influenced human civilization. Popularized by authors like Erich von Däniken in his book Chariots of the Gods, it suggests that ancient structures like the Egyptian pyramids or the Nazca lines were built with alien assistance. Updates in 2025 include new episodes of the History Channel's Ancient Aliens, such as Top 3 Alien Mysteries of Summer 2025, Exploring Cosmic Connections, and Were Earth's First Stories About Alien Visitors. From Season 11, Episode 7, delving into prehistoric narratives that might describe extraterrestrial encounters. A YouTube compilation from the show discusses buried secrets and potential alien artifacts, while the Ancient Aliens live tour extends these ideas experientially. On Quora and Reddit, discussions persist. One user queried the theory's evidence, noting ancient drawings resembling spaceships, while another subreddit thread debates its plausibility in Balkan contexts. Yet, what if these ancient astronauts were not from the stars at all, but from Earth's own deep past? What if the beings depicted in cave art or Sumerian tablets were survivors of a pre-dinosaur civilization, their technology mistaken for divine intervention? This framing shifts the narrative from cosmic visitors to terrestrial predecessors, aligning with the Silurian Hypothesis. Imagine a society that mastered flight or energy manipulation millions of years before us, their remnants scattered in anomalous fossils or geological oddities. Artificial intelligence is now aiding this quest. Swiss Cognitive's October 2024 article lists 5 archaeological discoveries made by AI, from mapping Peruvian geoglyphs to decoding charred papyri from Herculaneum. A September 2024 piece from The Debrief highlights AI revealing over 300 new Nazca geoglyphs, suggesting patterns that could indicate advanced planning. Even in Switzerland, LIDAR technology is uncovering hidden Roman sites, as per an April 2025 Swissinfo article, demonstrating how modern tools peel back layers of time. These revelations compel us to question our arrogance. Are we the pinnacle of evolution, or just a fleeting chapter in Earth's long saga? The absence of definitive proof does not negate the possibility. It merely underscores how adept our planet is at concealing its mysteries. As we ponder these enigmas, hello, this is Mr. H from Mystery History for Sleep, your guide through the whispers of the past that lull you into dreams of discovery. If these shadows of ancient worlds intrigue you as much as they do me, consider subscribing to the channel and turning on notifications. That way, you'll never miss our next nocturnal exploration into history's hidden realms. Now, let us continue unraveling this thread, for the question lingers: if such a civilization existed, what cataclysm erased them so completely, and could we be next in line to fade into the geological record? In the hushed galleries of museums around the world, artifacts gather dust behind glass cases, each one whispering tales of bygone eras. But some pieces refuse to fit neatly into the puzzle of history, defying explanation and sparking endless debate. These are the out-of-place artifacts, or OOPArts, enigmatic objects that appear in geological layers far older than any known human hand could have crafted them. Picture this: a perfectly spherical metallic object, etched with precise grooves, unearthed from rock beds formed billions of years ago in a South African mine. Known as the Klerksdorp spheres, these curiosities have puzzled experts since their discovery in the late 20th century. Measuring just a few centimeters across, they exhibit a symmetry and composition that some argue could only result from intelligent design, perhaps from a civilization predating even the simplest multicellular life. Skeptics point to natural processes like concretion formation in pyrophyllite deposits, where minerals harden into rounded shapes over eons. Yet, the grooves, 3 parallel lines encircling some spheres, evoke images of machined precision, as if they were components of an ancient device lost to time. Delving deeper into this riddle, one cannot ignore the broader category of OOPArts that challenge our understanding of prehistoric timelines. Consider the London hammer, a tool-like object encased in Ordovician rock from the mid-19th century find in Texas. The rock itself dates to an era when sea creatures dominated the planet, long before land-dwelling animals emerged. The hammer's iron head, with a wooden handle partially turned to coal, suggests it was embedded during the rock's formation. Proponents of anomalous history see it as evidence of advanced metallurgy in a time when no such technology should exist. Mainstream geology counters with explanations of rapid mineralization, where objects can become encased in sediment over mere centuries due to chemical reactions. Still, the intrigue lies in the details. Metallurgical analysis reveals the iron's unusual purity, resistant to corrosion, in ways modern replicas struggle to match. Is this a relic from a forgotten smithy, or simply a misplaced 19th century tool accelerated into fossil-like preservation by natural whims? As we peel back these layers of mystery, the conversation inevitably turns to fossils that blur the lines between natural evolution and something more orchestrated. The Ediacaran biota, those soft-bodied organisms from sediments laid down over 500 million years ago, stand as prime examples. Found in sites like the hills of South Australia or the cliffs of Newfoundland, these impressions resemble nothing in the modern world: disc-like forms, frond-shaped structures, and symmetrical patterns that hint at early experiments in multicellular life. Dickinsonia, a flat, segmented creature, leaves trails suggesting movement, yet its body plan defies classification as animal, plant, or fungus. Recent studies using advanced imaging techniques have revealed cholesterol molecules in their remains, pointing to animal affinities, but the fractal-like designs on some specimens evoke artificial symmetry, as if nature, or perhaps an unseen intelligence, was testing blueprints for life. Could these be the fossilized remnants of bioengineered entities from a pre-Cambrian society, or merely evolutionary dead ends wiped out by environmental shifts? The allure of such anomalies draws us into darker corners of speculation, where conspiracy theories intertwine with scientific scrutiny. Whispers in online forums suggest that governments or shadowy organizations suppress findings that could upend established narratives. For instance, tales of giant human-like skeletons unearthed in the early 20th century, some reportedly over 20 feet tall, circulate as evidence of prehistoric races with advanced knowledge. While most have been debunked as misidentified mammoth bones or outright hoaxes, a few accounts from reputable excavations persist, fueling ideas of antediluvian giants who might have coexisted with or predated dinosaur dominance. Balancing this, paleontologists emphasize that gigantism in fossils often results from allometric growth in isolated ecosystems, like the massive insects of the Carboniferous period, where high oxygen levels allowed dragonflies with wingspans rivaling eagles. Shifting our gaze to more tangible enigmas, the Antikythera mechanism emerges as a mechanical marvel from the ancient Mediterranean, recovered from a shipwreck off the Greek coast in the early 20th century. This geared device, dating to around the 2nd century before Common Era, functions as an analog computer predicting astronomical positions. Its sophistication, dozens of interlocking bronze gears, implies a level of engineering thought impossible without precursors. Some theorists link it to even older technologies, perhaps inherited from a lost civilization that influenced early Greek scholars. Modern X-ray tomography has revealed inscriptions and mechanisms simulating planetary motions, but the question remains, was this a standalone genius invention, or a surviving fragment of knowledge passed down from deeper antiquity? In a similar vein, the Baghdad batteries, terracotta jars from ancient Mesopotamia, filled with copper cylinders and iron rods, have been hypothesized as early galvanic cells for electroplating or medical uses. Experiments replicate weak electrical currents, yet skeptics argue they were mere storage vessels for scrolls. Venturing further into the prehistoric, we encounter fossils that seem to narrate stories of unnatural intervention. The Ica stones from Peru, a collection of engraved andesite rocks depicting humans alongside dinosaurs or performing advanced surgeries, surfaced in the mid-20th century. Numbering in the thousands, they portray scenes like heart transplants and telescopic observations, far beyond the capabilities of the ancient Nazca culture. While dismissed by many, as modern forgeries tests show artificial patina on some, the sheer volume and consistency intrigue investigators. Could a subset be genuine artifacts from a time when humans, or human-like beings, interacted with Mesozoic fauna? This ties into broader mysteries like the Paluxy River tracks in Texas, where apparent human footprints overlap dinosaur impressions in Cretaceous limestone. Initial excitement in the early 20th century gave way to erosion studies, revealing them as distorted theropod prints, but high-resolution scans continue to spark debate. Artificial intelligence is revolutionizing how we approach these puzzles, offering fresh perspectives on age-old anomalies. In recent years, machine learning algorithms have sifted through vast datasets of geological scans, identifying patterns invisible to the human eye. For example, AI has enhanced images of the Nazca lines, those enormous geoglyphs etched into the Peruvian desert, revealing figures that align with solstices and constellations. Some interpretations suggest they served as astronomical calendars or landing strips for ancient aircraft, though archaeologists favor ritualistic purposes tied to water cults. A breakthrough, detailed in a publication from Swiss Cognitive, highlights how AI uncovered hidden structures in satellite imagery, including potential underground chambers beneath the lines that could house OOPArts. This technology extends to fossil analysis. Neural networks trained on Ediacaran samples have proposed new classifications, grouping certain forms as proto-engineered, based on repetitive symmetries not found in later evolutionary branches. Amid these technological advances, conspiracy narratives persist, often amplified through social media. A notable thread from a popular platform discusses forbidden archaeology, claiming that institutions like the Smithsonian have hidden artifacts contradicting Darwinian timelines. One high-engagement post references a supposed 2024 leak of internal memos about suppressed finds from Antarctic expeditions, crystalline objects embedded in Precambrian ice, hinting at polar civilizations. While unverified, it echoes earlier tales from Operation Highjump in the mid-20th century, where explorers allegedly encountered anomalous structures. Balancing this sensationalism, scientific consensus holds that such claims stem from misinterpretations of glacial erratics or natural crystal formations. Exploring further, the grooved spheres of Ottosdal, akin to the Klerksdorp finds, emerge from pyrophyllite mines in South Africa, dated to nearly 3 billion years old. Their metallic composition, including hematite and goethite, resists easy categorization. Some analyses suggest they formed through metamorphic processes, yet the equidistant grooves on select specimens imply lathe work. A report from a reliable online archive posits they could be ancient ball bearings or ceremonial objects from a silicon-based intelligence, though geologists counter with evidence of nodule growth in mineral-rich environments. This debate underscores a core tension. When does natural geology cross into artificial creation? Turning to marine mysteries, deep-sea cores have yielded microfossils that defy standard classification. In sediments from the ocean floor, dating to the Devonian period, tiny spherical inclusions resemble manufactured beads, complete with uniform pores. Initial studies attributed them to volcanic glass or biogenic silica, but electron microscopy reveals internal structures akin to circuits. Could these be nanoscale relics of an aquatic civilization, thriving in primordial seas before continental shifts buried their legacy? This speculation aligns with theories of hydrothermal vent origins for life, where extreme conditions might foster rapid technological evolution. As we navigate these waters of wonder, the Piltdown Man hoax from the early 20th century serves as a cautionary tale. Once hailed as a missing link, this fabricated fossil, a human skull, paired with an ape jaw, fooled experts for decades before radiocarbon dating exposed the fraud. It reminds us that not all anomalies withstand scrutiny, yet genuine puzzles abound. The Taung Child, a hominid skull from the early 20th century South African find, pushes back human ancestry, but its context in Pliocene layers invites questions about parallel evolutions. In the realm of petrified oddities, the Koso artifact, a spark plug-like object encased in a geode from California, discovered in the mid-20th century, initially suggested modern technology in ancient rock. X-rays revealed a porcelain insulator and copper coil, but further investigation traced it to a 1920s champion spark plug, rapidly encrusted by iron oxide. Such cases highlight how everyday items can mimic profound mysteries through accelerated mineralization. Yet, persistent enigmas like the Iud aluminum wedge, found in Romanian riverbed sediments from the Pleistocene, composed of aircraft-grade aluminum alloy, resist dismissal. Its composition 89% aluminum with traces of copper and silicon mirrors, modern aviation materials. Yet the layer's age implies prehistoric smelting. Debunkers suggest it's a landing gear fragment from a World War II aircraft, but the absence of corrosion challenges that narrative. In weaving through these threads, one senses a tapestry of forgotten knowledge, where OOPArts and strange fossils hint at cycles of intelligence rising and receding like tides. The Kensington runestone, a slab from Minnesota inscribed with Norse runes, purportedly from the 14th century, speaks to pre-Columbian explorations, but its geological embedding suggests deeper antiquity. Linguistic analysis supports authenticity, yet skeptics cite forgeries. As we ponder these mysteries under the starlit canopy of history, I'm curious, where are you listening from tonight? Perhaps a quiet corner in London, a bustling cafe in Tokyo, or a desert outpost under a moonless sky. What hour is it there, as you unravel these enigmatic threads with me? The true secret lies not in proving these artifacts' origins, but in the questions they provoke about our world's hidden depths. Each sphere, each imprint, each anomalous bone invites us to imagine a history richer, stranger, and more interconnected than textbooks allow, urging us onward into the shadows of what might have been. The Bermuda Triangle, that infamous stretch of Atlantic where ships and planes have vanished without a trace, fueling decades of speculation. Conspiracy enthusiasts paint it as a portal to other dimensions, or a graveyard of alien experiments, where magnetic anomalies swallow vessels whole. Imagine the Flight 19 Squadron, a group of Navy bombers that disappeared in the mid-20th century, their last transmissions crackling with confusion before silence engulfed them. Some theories link this to extraterrestrial abductions, suggesting advanced beings use the area as a testing ground. Yet, peel back the layers, and science offers a more grounded, though no less dramatic, explanation. Rogue waves. These monstrous swells, towering up to 100 feet, can surge unexpectedly due to converging ocean currents and storm patterns. Recent investigations, including simulations from oceanographers, demonstrate how such waves could capsize even the sturdiest ships in seconds, leaving no wreckage. A documentary exploring this phenomenon posits that the triangle's reputation stems from statistical overstatement disappearances occur at rates similar to other busy maritime zones, amplified by human penchant for mystery. But what if these anomalies aren't cosmic traps, but remnants of an ancient terrestrial technology? Could submerged structures, misinterpreted as natural formations, be the decayed infrastructure of a pre-dinosaur society, their energy fields lingering to disrupt modern navigation? This pivot from alien intervention to Earth-born origins invites a fresh lens on classic conspiracies. Consider the enduring allure of the ancient astronauts theory, which posits that deities in global mythologies were actually extraterrestrial explorers. From the intricate carvings of Sumerian tablets depicting winged figures to the massive stone heads of Easter Island, proponents argue these feats required otherworldly assistance. In the late 20th century, this idea exploded into popular culture through books and television series, with episodes dissecting how Egyptian pyramids align with Orion's belt, hinting at stellar guidance. A compilation of such analyses suggests that ancient texts, like the Indian Vedas describing flying vimanas, describe aircraft powered by mercury vortex engines technology far beyond the Bronze Age. Skeptics counter that these alignments result from keen astronomical observations by human ingenuity alone, with no need for off-world tutors. Yet, the theory persists, evolving with new media. Live tours and streaming specials continue to unpack these puzzles, blending archaeology with speculation. Now, imagine flipping the script. What if these gods from the sky were not visitors from distant galaxies, but survivors or projections from Earth's deep past? This aligns with the Silurian Hypothesis, a thought experiment that probes whether we could detect an industrial civilization from millions of years ago. Rather than invoking aliens, it proposes that intelligent species, perhaps reptilian or cephalopod-like, achieved technological heights before cataclysmic events erased their traces. Discussions in scientific circles, including a bold article exploring this idea, emphasize that Earth's geological churn plate tectonics, recycling the crust, would obliterate most evidence. Chemical fingerprints, like unusual isotope ratios in sediment cores, might be the only survivors, easily mistaken for natural fluctuations. This hypothesis doesn't claim proof. It's a mirror reflecting our hubris, reminding us that humanity's brief flicker could vanish similarly, leaving future beings to ponder our existence as we do theirs. To keep the intrigue bubbling, let us venture into polar enigmas, where conspiracy meets the frozen unknown. Tales of cosmic wars beneath the South Pole circulate in shadowy corners, suggesting ancient battles between extraterrestrial factions left scars in the ice. One narrative describes anomalous heat signatures detected by satellites, interpreted as hidden bases or crashed vessels. While these often stem from misread data, natural geothermal activity, or research stations, the stories persist, weaving in elements like the mid-20th century expeditions that allegedly uncovered bizarre artifacts. Balancing this, geophysical surveys reveal that Antarctica's subglacial lakes and mountains are products of tectonic history, not interstellar conflict. Yet, applying the Earth-born angle, could these anomalies be vestiges of a pre-Ice Age civilization? Submerged continents or lost tech, preserved in permafrost, might explain magnetic disturbances akin to those in the Bermuda Triangle. Artificial intelligence adds a modern twist to this narrative, serving as a bridge between conspiracy and science. In recent advancements, AI systems reconstruct ancient wonders, digitally reviving lost cities and artifacts with stunning accuracy. For instance, algorithms trained on satellite imagery have unveiled hidden geoglyphs in remote deserts, patterns that conspiracy theorists link to alien landing sites. A breakthrough in deciphering Latin inscriptions uses neural networks to fill gaps in damaged texts, potentially unlocking secrets of forgotten knowledge. This technology extends to historical hypotheses. AI simulates evolutionary paths, modeling how an ancient intelligence might have developed tools or societies. One application recreates migration patterns from genetic data, challenging timelines of human origins and opening doors to pre-human scenarios. Skeptics warn of biases in training data, where AI might amplify myths if fed unbalanced inputs. Nevertheless, these tools foster humility, as a therapeutic exploration suggests using the Silurian framework to contemplate our impermanence, reducing existential anxiety by placing humanity in a cosmic continuum, delving into mythological crossovers, global lore brims with beings descending from heavens or emerging from underground realms. Norse sagas speak of frost giants and dwarven forges, while Mesoamerican codices depict feathered serpents guiding civilizations. Conspiracy circles tie these to ancient astronauts, proposing genetic engineering by visitors who jump-started human evolution. A counterview posits these as distorted memories of terrestrial forebears, advanced societies whose downfall, perhaps climate collapse or resource wars, scattered survivors to influence nascent cultures. Scientific balance comes from anthropology. Shared motifs arise from universal human experiences, like observing comets or eclipses, rather than literal encounters. Yet, the persistence of these tales across isolated societies hints at deeper connections, possibly archetypal echoes of lost epochs. As we probe further, the Nazca lines re-emerge as a focal point, those colossal etchings in the Peruvian plateau visible only from above. Traditional explanations frame them as ritual pathways or astronomical calendars, aligned with solstices. Conspiracy theories elevate them to runways for ancient aircraft, part of an alien network. Recent AI-enhanced discoveries, doubling the known figures, reveal humanoid and animal motifs with geometric precision, suggesting sophisticated planning. Could this be evidence of a pre-Incan intelligence using aerial surveys? Geological studies counter that wind erosion preserved these marks, with no extraterrestrial involvement needed. This duality keeps the debate alive, urging us to blend imagination with evidence. Venturing into oceanic depths, underwater anomalies like the Bimini Roadstone formations off the Bahamas coast stir similar debates. Resembling a paved pathway, some see it as Atlantis remnants or alien constructs. Marine geology attributes it to natural beach rock fracturing, yet sonar mappings reveal symmetrical alignments defying random processes. Linking back to the Bermuda Triangle, these could be sunken tech from an earthborne sieve, their magnetic properties disrupting compasses. Scientific dives confirm organic origins, but the symmetry tantalizes. In the realm of forbidden archaeology, suppressed finds allegedly rewrite history. Whispers of crystalline skulls with impossible craftsmanship suggest holographic data storage from ancient times. While many are modern carvings, a few exhibit tool marks inconsistent with known techniques. Conspiracy claims institutional cover-ups to protect paradigms, but peer review demands verifiable provenance. This tension embodies the balance. Embrace curiosity without abandoning rigor. Finally, as we circle back to humility, the Silurian lens transforms these conspiracies into therapeutic exercises. By entertaining pre-human civilizations, we confront our ephemerality, fostering empathy for the planet's long narrative. Suppose you were a geologist drilling into the heart of an ancient mountain, your core samples revealing layers upon layers of compressed history, each stratum a silent testament to cataclysms and rebirths. Suddenly, amid the expected bands of sediment and volcanic ash, you spot an irregularity, a spike in carbon isotopes that defies natural patterns, a whisper of synthetic compounds long since decayed. Is this mere coincidence, a quirk of planetary chemistry, or could it be the faint echo of an industrial powerhouse that flourished eons ago, its factories and power grids reduced to molecular ghosts? This is the essence of the Silurian Hypothesis, a provocative framework that doesn't just question our solitude in Earth's timeline, but invites us to hunt for the industrial fingerprints of civilizations that may have predated us by millions, perhaps billions, of years. At its core, the hypothesis challenges the assumption that humanity is the inaugural architect of technology on this world, named after fictional reptilian overlords from a classic science fiction series. It emerged from the collaborative minds of a NASA climate expert and an astrophysicist who pondered whether traces of advanced societies could linger in the geological record. Their inquiry wasn't born from wild fantasy, but from a desire to refine our search for life beyond Earth after all. If we can't spot evidence of hypothetical forebears on our own planet, how might we detect alien empires across the cosmos? The framework posits that any industrial era, much like our own, would leave subtle scars, alterations in atmospheric composition, anomalous sediments, or even the remnants of energy harvesting that altered the planet's rhythms. What makes this idea so tantalizing is its evolution in recent discussions, where fresh perspectives have breathed new life into the concept. For instance, explorations in astrobiology journals have linked it to the rapid emergence of life on habitable worlds, suggesting that intelligent societies could arise far quicker than previously thought. One such analysis argues that life might spark and evolve to complexity in a geological blink, opening the door for multiple cycles of civilization on a single planet. Imagine a world where, during the Carboniferous era, when lush swamps birthed the coal we mine today, a species harnessed geothermal vents or biomass fuels, their emissions subtly shifting the carbon cycle in ways we now detect as unexplained hyperthermals. These warm spikes, like the one that scorched the planet around 55 million years ago, are typically blamed on volcanic outbursts or methane releases, but the hypothesis urges us to consider engineered causes, vast deforestation for energy, or the unchecked burning of ancient fuels. Delving into these markers, we find a treasure trove of potential clues hidden in the Earth's archives. Carbon fingerprints stand out as prime suspects, ratios of lighter to heavier isotopes that skew unnaturally, hinting at massive fossil fuel combustion. Our own era, the Anthropocene, is etching such a signature into the strata, with plastics and nitrogen from fertilizers seeping into sediments. If a predecessor society mirrored this, their legacy might appear as puzzling deviations in deep core samples, easily dismissed as asteroid impacts or oceanic upheavals. Recent syntheses in scientific outlets have expanded on this, proposing that even sustainable technologies, solar arrays or hydroelectric marvels could leave geophysical tells, like altered river deltas or unusual erosion patterns from redirected waterways. The hypothesis gains momentum from analogies to our search for extraterrestrial intelligence. Astrobiologists scanning distant exoplanets for biosignatures now apply similar logic here at home. If a civilization tapped into nuclear fission or fusion, radioactive isotopes with unnatural half-lives might persist in trace amounts buried in ocean floor, mud, or polar ice caps. Picture coring into Antarctic glaciers and finding plutonium-244, an element absent from natural terrestrial processes, its presence a smoking gun for artificial reactors. While no such finds have surfaced, the absence doesn't disprove the possibility. It merely highlights the planet's prowess at erasure. Plate tectonics, that slow conveyor belt of crust, subducts old seabeds into the mantle, melting away evidence over hundreds of millions of years. Most oceanic crust we see today is younger than the dinosaurs, recycled in fiery depths, carrying any ancient secrets to oblivion. To keep the curiosity aflame, consider how this framework intersects with deep time extinctions, those mass die-offs that punctuate the fossil record. The Permian Triassic event, which wiped out over 90% of marine species, is often linked to volcanic supereruptions in what is now Siberia. But overlay the Silurian lens, and new questions arise. Could runaway industrial pollution have amplified such a catastrophe? Imagine a society whose emissions triggered ocean acidification, collapsing food chains and sparking a chain reaction of biodiversity loss. Sediments from that era show geochemical oddities, sulfur, isotopes, suggesting anoxic waters, mercury spikes indicating widespread contamination. These could be volcanic byproducts, yet they mirror what our models predict for unchecked human industry. Recent modeling in climate studies reinforces this parallel, showing how even a short-lived technological boom could imprint lasting anomalies, detectable eons later if we know where to look. Shifting gears to the microbial realm, the hypothesis draws intrigue from events like the Great Oxygenation, when photosynthetic bacteria flooded the atmosphere with a gas toxic to many early life forms. This planetary makeover, occurring billions of years ago, reads like a cautionary tale of unintended consequences, much like how a hypothetical civilization might have geoengineered their world, only to unleash feedback loops that doomed them. Modern analogues abound. Our ozone depletion and greenhouse gas buildup could etch similar scars. If predecessors experimented with atmospheric tinkering, say, seeding clouds for weather control or dispersing aerosols to combat warming, their efforts might manifest as stratigraphic blips, like sudden ozone proxies or halide anomalies in ice cores. The beauty of this thought experiment lies in its call for methodological innovation. Traditional paleontology hunts for bones and footprints, but detecting industrial ghosts demands interdisciplinary sleuthing. Geochemists analyzing isotope gradients, climatologists modeling hypothermal triggers, and even biologists sequencing ancient DNA for signs of genetic tampering. Suppose a society bioengineered crops or livestock. Mutated genomes might persist in descendant species, subtle markers of artificial selection buried in modern biodiversity. Recent advances in metagenomics have unearthed viral fossils in permafrost, hinting at past pandemics. Could engineered pathogens from a fallen empire explain unexplained die-offs in the record? As we probe these possibilities, the hypothesis evolves beyond mere speculation into a mirror for our own trajectory. It prompts us to catalogue what our civilization might bequeath to future strata: microplastics infiltrating every ocean layer, forever chemicals like PFAS defying degradation, or the radioactive legacy of nuclear tests. These aren't just pollutants, they're potential beacons for distant descendants, who might puzzle over our brief flare as we do over enigmatic events like the Younger Dryas cooling. That abrupt chill, marking the end of the last ice age, is debated as comet impact or meltwater flood, but whisper the Silurian angle, and it becomes a possible relic of geoengineering gone awry, a desperate bid by ancients to stabilize their climate. Fueling this narrative are fresh voices in the discourse, where thinkers riff on the idea's implications for legacy and volunteering, framing it as a meditation on impermanence. One exploration posits cephalopods as plausible candidates for such a society: octopuses, with their distributed intelligence and tool use, evolving in oceanic realms where evidence would dissolve swiftly. Their short lifespans and rapid adaptation could spawn a fleeting empire, its innovations lost to currents and pressure. Another angle ties it to abiogenesis: speed, arguing life's quick start on habitable worlds implies multiple intelligent blooms per planet, each leaving faint industrial echoes. Intriguingly, the hypothesis intersects with speculative evolution communities, where enthusiasts imagine Silurian worlds teeming with plausible precursors, avian intelligences in the Cretaceous, or mammalian societies in the Eocene. These visions aren't scientific canon but spark creativity, urging us to envision how such beings might industrialize, perhaps harnessing bioluminescence for energy or symbiotic fungi for computation. The fossil gaps, those missing chapters in the record, become fertile ground for these musings, where absence invites invention. Yet, to temper the excitement, we must acknowledge the hypothesis's skeptics. They argue that, without falsifiable evidence, say, unambiguous technosignatures like layered plastics in Precambrian rock, it's unfalsifiable fancy. Our geological surveys, deep as they go, sample but a fraction of the crust. Vast swaths remain unexplored, from abyssal plains to mantle boundaries. Drilling projects like those probing ancient craters have unearthed surprises, like microbial life in extreme depths, but no smoking guns for industry. This scarcity doesn't debunk the idea. It underscores the need for refined tools, perhaps quantum sensors detecting isotopic anomalies or AI sifting petabytes of core data for patterns. In weaving these threads, the Silurian hypothesis transcends academia, becoming a philosophical compass. It humbles us, positioning humanity not as the apex but as a transient player in a grand, cyclical drama. If predecessors existed, their downfall, be it ecological hubris or cosmic misfortune, serves as a harbinger, urging sustainable paths. Our satellites and probes, scanning the heavens, might one day confirm similar cycles on exomoons or rogue planets, But until then, Earth's strata hold the keys. So, as we sift through the dust of ages, each anomaly beckons. Is this nature's caprice, or the muted cry of a lost world? Have you ever wondered what it would feel like to be the Earth itself? A colossal entity spinning through the void, your skin of rock and water constantly reshaping under the relentless forces of change. Imagine embodying this living planet, feeling continents drift like slow-moving scars across your surface, oceans swelling and receding as breaths in a cosmic rhythm. You would witness eons unfold not as abstract timelines, but as visceral transformations, mountains thrusting upward only to crumble into dust, vast forests petrifying into coal seams, and entire biospheres blooming and withering in what feels like fleeting moments. This is the realm of deep time, a scale so immense it dwarfs human comprehension, where the Earth's own mechanisms act as an unforgiving editor, erasing chapters of history with indifferent precision. Through subduction zones swallowing oceanic crust, erosion carving away landscapes, and volcanic fury overlaying fresh layers, the planet relentlessly recycles itself, leaving us to piece together a narrative from scattered fragments. But in these acts of obliteration lie hidden tales of forgotten eras, epochs where life might have experimented with forms and intelligences we can scarcely imagine, their legacies obscured but not entirely lost. As the Earth, you would recall your fiery birth from a molten nebula cooling into a habitable orb over billions of cycles around the Sunday. Your earliest memories are of the Hadean Eon, a hellish phase of asteroid bombardments and magma oceans, where no surface remained stable long enough for life to take hold. Yet, even then, the seeds of transformation stirred water condensing from volcanic outgassing, forming primordial seas that would cradle the first sparks of biology. Transitioning into the Archean, your atmosphere thickened with methane and ammonia, fostering simple microbes that clung to hydrothermal vents, their metabolisms slowly altering your chemistry. These tiny architects triggered the Great Oxygenation Event, a planetary revolution where photosynthetic organisms pumped oxygen into the air, poisoning anaerobic kin and paving the way for more complex life. To you, this was no mere biochemical shift. It was an apocalypse for early inhabitants, a reset that buried entire ecosystems under oxidizing sediments, their existence inferred only from faint chemical signatures in ancient rocks like those in Western Australia. The intrigue deepens as you reflect on how these resets multiply across your vast lifespan. In the Proterozoic Eon, following the oxygenation, your surface hosted strange microbial mats and the first hints of multicellularity. But massive glaciations, global snowballs froze, oceans solid, entombing potential evolutionary leaps in ice. Emerging from these chills, life diversified in fits and starts. Yet much of this era remains an enigma, with rock records sparse due to your ceaseless tectonic dance. Continents collided and rifted, forming supercontinents like Rodinia, whose assembly and breakup redistributed life forms, submerging some habitats while uplifting others. As the Earth, you feel the weight of these movements, plates grinding with inexorable force, subducting evidence of ancient shores into your mantle's fiery crucible. This process, known as the Wilson cycle, ensures that over 90% of your oceanic crust is younger than 200 million solar orbits. Any older secrets melted and reformed into new basalt. What keeps the story captivating is the way these erasures create pockets of mystery, where forgotten eons tease us with glimpses of what might have been. Take the Cryogenian period, a time of extreme cold where your entire surface may have iced over, halting biological progress for millions of revolutions. Emerging into the Ediacaran, soft-bodied organisms etched enigmatic impressions in sediments, their forms, discs, fronds, and quilts defying easy links to modern phyla. Were these the precursors to the Cambrian explosion, or relics of a parallel evolutionary path snuffed out by environmental whims? Your preservation bias favors hard-shelled creatures, leaving soft tissues to dissolve, yet rare Lagerstätten, exceptional fossil sites offer windows, like the Burgess Shale, where bizarre arthropods and worm-like oddities reveal a burst of diversity. But for every preserved snapshot, countless narratives vanish, subducted or eroded, fueling speculation about lost intelligences that might have arisen in these gaps. To infuse fresh wonder, envision comparing your terrestrial churn to the static worlds of other celestial bodies. On Mars, with its dormant tectonics, ancient craters and riverbeds endure as pristine scars, potentially harboring traces of microbial life from a wetter past. Recent rover missions have sampled basalts hinting at hydrothermal activity, environments where life could have thrived billions of solar cycles ago. If the red planet once hosted simple organisms, why not you, Earth, with your dynamic history, birthing and burying multiple waves of complexity? This parallel underscores your unique amnesia. While Mars preserves its youth, you actively forget, your mantle convection erasing surface memories like a palimpsest rewritten endlessly. Astrobiologists draw from this, modeling how habitable worlds might cycle through habitable phases, each potentially spawning intelligent life, only for geological forces to enter it. The narrative twists with recent revelations that push back timelines of human-like presence, suggesting your history of habitation runs deeper than once thought. Footprints etched in New Mexico's alkaline flats, preserved in gypsum layers, indicate bipedal wanderers traversing your landscapes far earlier than expected, their steps mingling with those of megafauna. These impressions, analyzed with optical dating, challenge migration models, implying waves of arrivals that interacted with your evolving ecosystems. Extending this logic to pre-dinosaur epochs, one ponders if similar traces perhaps from non-human walkers lie buried, their subtlety lost to your erosive touch. In African rift valleys, hominid tools from Pliocene sediments reveal sophisticated napping, but imagine analogous artifacts from Devonian shores, dissolved by acidic rains or crushed under shifting plates. Your great oxygenation, often hailed as life's triumph, doubles as a tale of devastation, where oxygens rise corroded iron-rich oceans, precipitating banded formations that stripe your oldest cratons. These rust-red layers, visible in Pilbara outcrops, chronicle a shift that exterminated anaerobes, clearing niches for aerobic innovators. As the Earth, you sense this as a pivotal purge, akin to how a hypothetical civilization's emissions might trigger cascading collapses. Recent microbial studies from deep-sea vents echo this, showing extremophiles thriving in conditions mimicking your early state, their resilience hinting at life's tenacity amid resets. The Proterozoic's latter phases intrigue with glimmers of complexity. Stromatolites, those layered domes built by cyanobacteria, carpeted your shallow seas, their structures foreshadowing communal architectures. Yet, supercontinent breakups flooded shelves with nutrients, sparking blooms that depleted oxygen, creating anoxic dead zones recorded in black shales. These dark bands, rich in organics, preserve rare fossils but swallow others, your sedimentary vaults selective in what they safeguard. In the Neoproterozoic, extreme swings from snowball glaciations to hothouse thaws tested life's limits, perhaps fostering adaptations that prefigured intelligence, only for tectonic upheavals to scatter evidence. Shifting to space analogies adds layers of fascination. Your moon's craters, pocked from impacts, contrast your smoothed visage, where erosion and biology collaborate to heal wounds. Meteor strikes that scarred you in the late heavy bombardment left subtle imprints, like iridium layers marking the dinosaurs' demise, but earlier barrages might have sterilized budding societies, their remnants vaporized. Astrobiology probes, scanning Venus's hellish surface or Europa's icy shell, seek biosignatures that mirror your hidden past hydrothermal plumes or subsurface oceans where life persists undetected. The Permian era's close, a boundary of near-total extinction, exemplifies your erasure prowess. Volcanic floods in Siberian traps, belched gases, acidifying oceans and warming climates, decimating 90% of species. Sediments from this juncture show mercury spikes and isotopic chaos, signatures of global trauma. As the Earth, you absorb these losses, your biosphere rebounding with new dominants, dinosaurs rising from reptilian survivors. But in quieter intervals, like the Carboniferous, Insect giants buzz through oxygen-rich air, their fossils rare due to delicate exoskeletons dissolving in humid soils. Recent paleontological hauls from Antarctic outcrops reveal Permian ecosystems teeming with therapsids, mammal-like reptiles whose burrows suggest social behaviors. These finds, unearthed in recent expeditions, hint at cognitive leaps, perhaps precursors to intelligence, buried under ice until climate shifts exposed them. Your polar caps, melting under modern warmth, unveil such secrets, reminding us that erasure is never absolute patience, and technology can resurrect fragments. In the Devonian, fish fin through coral seas, evolving limbs that would conquer land, but mass die-offs from anoxic events pruned branches, their causes debated as asteroid hits or algal overgrowths. Your sedimentary record, folded in Appalachian folds, preserves these transitions, yet vast tracts subducted leave blanks. The Ordovician radiation, a surge of marine diversity, ended in glaciation, ice sheets grinding habitats into till. Your core mystery resides in the Precambrian, 88% of your chronicle, where zircon crystals from Australian sands hold water inclusions from your infancy, suggesting early oceans. These grains, enduring metamorphism, whisper of lost continents, their zircons detrital clues to eroded highlands. As the Earth, you harbour these in your mantle, occasionally erupting them in lavas. The narrative captivates through these veiled epochs, where your erasure fosters speculation. Did intelligences arise in Proterozoic warmth, their traces subducted? Recent metagenomic dives into ancient rocks detect viral shadows, implying complex interactions predating visible fossils. Your great resets, from oxygen crises to snowball episodes, mirror potential sieve-induced collapses, urging reflection on our stewardship. In essence, deep time isn't a void but a canvas of possibilities, your surface a palimpsest of overwritten sagas. Each layer peeled reveals tantalizing hints, inviting us to decode your enigmatic autobiography, where oblivion breeds eternal curiosity. As these ancient rhythms lull us toward rest, I find myself wondering what dreams they'll stir in you tonight. If these veiled epochs have sparked your own reflections on the world's hidden pulses, feel free to drop a comment below, perhaps a favorite forgotten era or a question about the resets that shaped us. Deep beneath the surface of our world, where the weight of countless millennia presses down like an invisible hand, lies a silent language etched into the rocks themselves, a code of chemical whispers and geological riddles that might just reveal the handiwork of intelligences long vanished. Imagine tracing your fingers over a core sample pulled from the ocean floor, its layers a striped chronicle of planetary breaths, and spotting a sudden jolt in carbon ratios, a deviation so sharp it screams of disruption. This is the carbon fingerprint, not a mere smudge from natural cycles, but potentially the lingering scar of an ancient industry's excess, where massive fuel burns or chemical releases tilted the atmospheric scales. In our own time, humanity is inscribing such a mark through fossil fuels, pumping lighter carbon isotopes into the air and oceans, creating a detectable anomaly that future geologists might puzzle over as evidence of our fleeting dominance. But what if similar spikes in the deep past weren't volcanic belches or asteroid fallout, but the exhaust of forgotten engines powering societies that rose before the continents settled into their current shapes? The fascination builds when you consider how these fingerprints manifest in unexpected ways, turning ordinary rock into a canvas of intrigue. Take the enigmatic layers from a thermal maximum event that gripped the planet after the dinosaurs' fall, where temperatures soared and ecosystems reeled. Sediments from that era show a flood of light carbon, akin to what we'd expect from widespread combustion, perhaps, vast wildfires, or something more orchestrated, like the byproducts of an energy-hungry civilization collapsing under its own weight. Scientists have long attributed this to methane bursts from thawing permafrost or oceanic clathrates, but the precision of the isotope shift invites a tantalizing alternative. Could it echo the fallout from ancient reactors or synthetic processes? As you ponder this, the story unfolds like a detective novel, with each core sample a clue, urging you to connect dots across vast temporal chasms. Recent modeling in climate labs has simulated such scenarios, showing how even a short burst of industrial activity could imprint these signatures, lingering as faint echoes in carbonate rocks or ice cores, waiting for sharp-eyed analysts to notice. Venturing into the realm of metallic mysteries adds another layer of allure, where concentrations of rare elements in ancient strata defy easy explanations. Picture sifting through Precambrian shales and finding spikes in platinum or iridium, metals we associate with catalytic converters or high-tech alloys. While asteroid impacts famously deposit iridium like the thin layer marking the end of the Cretaceous, these anomalies sometimes appear without crater evidence, clustered in ways suggesting localized sources. Could they be the dispersed remnants of mined ores or refined products from a bygone era? In our industrial age, mining leaves telltale tailings, heavy metals leaching into soils and waterways, creating geochemical hotspots. If predecessors delved into your Earth's bounty for similar purposes, their waste might persist as subtle enrichments, easily mistaken for hydrothermal vents or cosmic dust fallout. The thrill comes from recent analytical breakthroughs using mass spectrometry, which tease apart these signals with unprecedented resolution, revealing patterns that hint at artificial concentration rather than random deposition. The narrative takes a mesmerizing turn with synthetic molecules, those long-chain polymers that don't arise naturally but scream of laboratory origins. Plastics, born from our petrochemical wizardry, now infest every corner of your planet, from mountain peaks to abyssal trenches. But envision finding trace hydrocarbons in Eocene mudstones, structures resembling degraded polyethylene, their bonds twisted by time yet unmistakable. Skeptics would point to biogenic oils or kerogen from ancient algae, but the chain lengths and branching could betray engineered design, perhaps packaging from a lost logistics network or insulation from submerged cables. This isn't idle fancy. Lab recreations show how UV radiation and microbial action break down synthetics over millennia, leaving microfragments that embed in sediments. As you delve deeper, the curiosity peaks with the possibility of chiral anomalies, where molecular handedness skews unnaturally, a hallmark of synthetic chemistry that nature rarely mimics with such bias. Geological enigmas weave in seamlessly, transforming mundane formations into portals of speculation. Banded iron layers, those rust-hued stripes in your oldest exposed rocks, chronicle the oxygenation saga, but their rhythmic precision sometimes baffles, with thicknesses suggesting pulsed events rather than steady accumulation. While cyanobacteria get the credit, imagine if an early intelligence manipulated iron-solubilizing bacteria for mining or waste disposal, accelerating the process and leaving these bands as inadvertent monuments. The story captivates further with polystrate fossils, trees, or reeds, piercing multiple sediment layers, as if time compressed around them. Conventional wisdom cites rapid burial from floods or volcanic ashfalls, but their upright poise in coal seams evokes engineered preservation, perhaps ancient carbon sequestration experiments gone awry. In Appalachian exposures, these upright trunks span what seem like eons, their carbonized bark, a testament to sudden entombment, sparking thoughts of catastrophic interventions by thinking beings. Spherules, those tiny glassy beads scattered in certain strata, add a sparkle of mystery, often linked to meteor impacts where molten droplets rain down and cool. Yet some layers host them without shock quartz or crater scars, their compositions laced with nickel or chromium in ratios hinting at smelting rather than cosmic delivery. As you trace their distribution, the plot thickens with findings from deep-sea drills, where these microspheres cluster in patterns suggesting atmospheric fallout from distant forges. Recent electron probe analyses have isolated exotic inclusions within them, elements like rare earths that concentrate in industrial slags, blurring the line between geology and artifact. The allure intensifies with radioactive whispers, isotopes whose decay clocks tick at unnatural paces. Uranium's natural fission leaves predictable daughters, but anomalies like excess helium in zircon crystals could signal artificial reactors, their heat signatures baked into surrounding minerals. Picture ancient containment breaches, dispersing fission products that now appear as isotopic excesses in granite intrusions. While geothermal hotspots explain some, the clustering in non-volcanic zones teases other origins, perhaps power plants fueling underwater habitats in Paleozoic seas. This ties into broader geochemical puzzles, like mercury volatilization events recorded in lake beds, where spikes align with extinction horizons, possibly from coal-fired emissions or alchemical pursuits of yore. Sediment stories unfold with their own twists, where abrupt changes in grain size or composition hint at landscaped alterations. River deltas bloated with silt might reflect ancient agriculture's erosion, much as our dams reshape coastlines today. In Triassic red beds, laminated sequences break suddenly into chaotic mixes, as if massive earthworks disrupted natural flows. The excitement builds with paleosol profiles, ancient soils preserving root traces or burrows that suggest managed ecosystems, their carbon content skewed by intensive farming. As you excavate these narratives, microbial biomarkers emerge, lipids from engineered bacteria, perhaps designed for bioremediation, their signatures enduring in kerogen. Vitrification events, where sands fuse into glassy slabs, evoke high-energy mysteries. Lightning or meteors can create fulgurites, but widespread sheets in desert pavements suggest broader causes, perhaps focused energy beams from ancient tech. In African dunes, these glassy expanses span acres, their melt patterns uniform in ways natural fires struggle to replicate. The curiosity peaks with embedded anomalies, like metallic inclusions that resist weathering, hinting at slag from fusion processes. Mineral veins laced with unexpected alloys add to the tapestry, where gold threads through quartz in patterns defying hydrothermal norms. In Archean greenstones, these deposits cluster with rare elements, as if concentrated by selective extraction. Recent isotopic dating ties them to mantle upwellings, but the enrichment ratios whisper of refining techniques, perhaps electrolytic separations lost to time. As the layers accumulate, the carbon fingerprint reasserts itself, intertwining with these enigmas to form a cohesive puzzle. Anomalous spikes in Devonian black shales, rich in organics, show deuterium depletions akin to industrial fractionation, possibly from synthetic fuel production. The narrative enchants with the possibility of integrated signals, a carbon jolt paired with metallic spikes and vitrified zones, clustering in what might have been industrial heartlands, now subducted or eroded, but leaving peripheral clues. The Earth's cryptic geology, from banded ions to spheral rains, forms a labyrinth of potential signs, each turn revealing new possibilities. These aren't definitive proofs, but invitations to wonder, blending chemistry's precision with imagination's breadth. In tracing these fingerprints, we uncover not just past secrets, but reflections of our own path, urging vigilance lest our marks become the next enigma for distant eyes. Envision a world where intelligence doesn't wear a human face, where minds pulse not in grey matter encased in skulls, but in distributed networks of neurons firing across tentacles or exoskeletons, solving puzzles that would baffle our linear thoughts. What if, in the shadowed corridors of evolutionary history, cleverness emerged not once, but repeatedly, in forms so alien to us that we've overlooked their legacy? This isn't about anthropomorphic fantasies. It's a dive into the kaleidoscope of life's adaptive ingenuity, where octopuses camouflage with chameleon, like precision, crows forge tools from twigs, and even fungi communicate through underground webs spanning acres. These modern marvels hint at deeper possibilities, intelligences that might have flourished before mammals claimed the stage, their cognitive feats woven into the fabric of survival, only to fade as environments shifted and new dominance arose. The question tantalizes, could such minds have built societies, manipulated their worlds, or even pondered their existence, leaving us to wonder if we're merely the latest iteration in a parade of thinkers? Let's wander through this evolutionary labyrinth, starting with the cephalopods, those eight-armed enigmas of the deep, whose brains defy centralization. An octopus doesn't think like we do. Its intelligence is decentralized, with 2/3 of its neurons residing in its limbs, allowing each arm to problem-solve independently. Watch one unscrew a jar to snag a crab, or change color not just for camouflage, but to signal complex emotions. In controlled settings, they've demonstrated memory, learning, and even play behaviors once thought exclusive to vertebrates. This sparks curiosity. If modern octopuses, descendants of Cambrian ancestors, exhibit such prowess, what might their prehistoric kin have achieved in oceans teeming with opportunity? During the Ordovician, when seas brimmed with diverse invertebrates, a cephalopod lineage could have evolved heightened awareness, perhaps coordinating hunts or crafting shelters from coral debris. Their soft bodies rarely fossilize, but rare impressions in Silurian slates show coiled shells with hints of manipulative appendages, inviting speculation about early tool use or social signaling. The intrigue multiplies when we consider avian intellects, birds whose brains, though small, pack dense neural punch. Corvids like ravens cache food with foresight, remembering locations months later and even deceiving rivals by faking hides. In urban jungles, they've adapted to traffic lights, dropping nuts at crosswalks for cars to crack. This adaptability echoes deeper evolutionary roots. During the Cretaceous, when feathered dinosaurs took wing, birds might have developed similar smarts in response to predatory pressures. Fossilized nests from that era show intricate arrangements, suggesting parental planning beyond instinct. What if a lineage of these aerial thinkers evolved communal strategies, sharing knowledge across flocks in ways that mimicked early cultures? Their lightweight frames leave fragile traces, but beak marks on petrified seeds hint at selective foraging, a step toward intentional cultivation. Venturing into mammalian precursors adds layers of wonder, with therapsids from the Permian era showcasing traits that foreshadow our own cognition. These reptile-mammal hybrids, with their upright postures and varied dentition, burrowed in family groups, their fossils revealing care for young through preserved dens. Recent exhibits highlight Permian monsters like the sailback Dimetrodon, but lesser-known forms like Gorgonopsians displayed predatory cunning, their skulls housing enlarged brain cases for enhanced senses. In museum reconstructions, these creatures evoke a world where pack hunting required coordination, perhaps early forms of communication through vocalizations or postures. This era's end, a massive die-off, might have culled budding intelligences, but survivors carried forward genetic whispers of that potential, evolving into mammals that would later dominate. The story takes an unexpected twist with quantum biology, a field exploring how life exploits quantum effects for efficiency. Photosynthesis in algae harnesses superposition to root energy paths, while birds navigate using quantum entanglement in eye proteins sensitive to magnetic fields. This suggests ancient life might have leveraged such phenomena for vibrational intelligence, where molecular oscillations facilitated rapid information processing. In Precambrian microbial mats, collective behaviors synchronizing metabolisms across colonies could represent proto-minds, decision-making at a quantum scale. Imagine stromatolites pulsing with coherent vibrations, optimizing resource sharing in ways akin to neural networks. Recent lab simulations show bacteria exhibiting quantum-like tunneling in enzyme reactions, hinting that early evolution toyed with these mechanics long before complex brains emerged. Fungi enter the fray as underground maestros, their mycelial networks sprawling like neural webs, exchanging nutrients and signals across ecosystems. The wood wide web connects trees, allowing warnings of pests or sharing sugars, a form of communal intelligence without a central hub. Fossilized mycelia from Devonian soils show similar interconnectivity, suggesting ancient forests thrived on fungal alliances. Could a fungal-dominated intellect have arisen in carboniferous swamps, where spore-based communication orchestrated vast biomes? Their resilience surviving extinctions through spores makes them stealthy candidates for persistent smarts, influencing evolution subtly over eons. Insects, with their hive minds, offer collective brilliance that challenges solitary notions of intelligence. Ant colonies farm aphids, build climate-controlled nests, and wage wars with strategy, decisions emerging from pheromone trails and interactions. Termite mounds, engineered with ventilation shafts, maintain stable internals despite external swings. During the Carboniferous, when oxygen levels soared, insect giants like Meganeura, with hawk-sized wingspans, might have coordinated in swarms, their neural simplicity amplified by numbers. Fossilized nests from that time show labyrinthine designs, implying architectural foresight. This swarm intelligence could prefigure societal structures, where the whole exceeds individual parts. The evolutionary dance fascinates with its contingencies, random mutations meeting environmental pressures, birthing novelties like echolocation in bats or tool-making in primates. But permanence isn't assured. Intelligence might be a double-edged blade, enabling dominance yet inviting overreach. Predatory overspecialization or habitat dependency could doom clever species, as seen in Neanderthals' fade amid climate shifts. Extending this to pre-dinosaur realms, a clever arthropod or mollusk might have thrived briefly, only for tectonic upheavals to shatter their niches. Elephants and dolphins amplify the theme with their social bonds and self-awareness. Elephants mourn dead, using trunks for intricate tasks, while dolphins employ signature whistles as names, coordinating hunts with bubble nets. Their aquatic or terrestrial adaptations trace to Eocene divergences where mammalian brains ballooned. Fossil cetacean skulls show enlarged auditory regions, suggesting early echolocation sophistication. Could parallel paths in earlier eras, say ichthyosaur packs in Jurassic seas, have fostered similar group minds? The plot thickens with hybrid forms, like the platypus blending mammalian, reptilian, and avian traits, its electroreceptive bill detecting prey vibrations. This mosaic evolution hints at modular intelligence, pieced from ancestral toolkits. In Cambrian bursts, when body plans exploded, segmented worms with proto-brains might have experimented with sensory fusion, precursors to distributed cognition. Quantum biology re-emerges, with magnetoreception in microbes suggesting ancient navigation via Earth's fields, perhaps guiding migrations or alignments. Recent biophysics explorations show enzymes exploiting quantum tunneling for efficiency, implying life's quantum roots stretch to your planet's dawn. Permian exhibits, showcasing saber-toothed predators and burrowing herbivores, reveal behavioral complexity through trackways, indicating herding. These monsters navigated diverse landscapes, their fossils in red beds preserving snapshots of adaptability. Dinosaurs themselves intrigue, with some theropods showing brain-to-body ratios rivaling birds, suggesting pack-hunting smarts. Fossil nests with arranged eggs imply parental investment, while track sites reveal social trails. A recent online discussion posits engineered traits in these beasts, but evolution's hand suffices natural selection sculpting survivors. The narrative's richness stems from these intersections: catastrophe meeting choice, nature entwining with nurture. Each possibility mirrors our dilemmas, from climate brinkmanship to ethical AI. If they chose fade, perhaps for balance. If self-destructed, a warning against excess. In our genes or myths, do their lessons linger, guiding us unwittingly? As these tales of vanished worlds weave through the quiet of the night, I wonder what endings you envision for our own story. If these mysteries of collapse and choice spark your curiosity, you might enjoy diving deeper into our Lost Civilizations playlist, where more ancient enigmas await to unravel under the stars. For now, let this exploration of forgotten falls carry you into dreams, where the echoes of those who came before might whisper paths to wiser futures. What if the vanishing act of an ancient civilization wasn't scripted by fate's cruel hand, but by a confluence of choices, calamities, and cosmic whims that left no witnesses to tell the tale? Envision a society at the peak of its ingenuity, their spires piercing primordial skies, only for the ground to tremble, the seas to rise, or their own ambitions to unravel the very threads holding their world together. This disappearance could stem from a tapestry of possibilities, each strand woven with elements of tragedy, hubris, or even deliberate grace. As we unravel these threads, the mystery deepens not just in how they fell, but in what their end reveals about the fragile dance between intelligence and survival. Could their story be a mirror to our own, a cautionary echo from the abyss, urging us to peer closer at the precipices we tread? Let's begin with the raw fury of natural cataclysms, those unstoppable forces that have reshaped the planet time and again. Picture a supervolcano awakening from slumber, its eruption blanketing the atmosphere in ash and sulfur, plunging the world into a volcanic winter where sunlight becomes a distant memory. Temperatures plummet, crops wither, and ecosystems collapse in a chain reaction of starvation and disease. In the geologic record, such events leave indelible marks, layers of tephra, and isotopic shifts, signaling global cooling. If an ancient intelligence thrived during a tectonically active era, a similar outburst could have sealed their doom, their cities buried under pyroclastic flows or their farmlands rendered barren. The intrigue lies in the subtlety. What if the Permian, Triassic boundary, that infamous reset wiping out most marine life, wasn't solely volcanic? Could a society's emissions have amplified the chaos, tipping a precarious balance into oblivion? This possibility tantalizes, blending natural wrath with unintended consequences, reminding us that even the mightiest can be felled by the Earth's indifferent convulsions. Asteroid impacts offer a more dramatic script, a celestial hammer striking without warning. Imagine a colossal rock hurtling from the void, slamming into the surface with energy rivaling millions of nuclear blasts. The immediate devastation, shockwaves, tsunamis, firestorms would be followed by a nuclear winter of dust-choked skies, acid rains scouring the land. The Chicxulub event, which ended the dinosaurs' reign, serves as a blueprint. A thin iridium layer marks the fallout, ecosystems reeling for millennia. For a pre-dinosaur society, a similar strike could erase them utterly, their artifacts vaporized or entombed in ejector blankets. But here's the curious twist. What if they saw it coming? With advanced observatories, perhaps they attempted deflection, only for miscalculations to doom them. This scenario sparks endless what-ifs. Did fragments of their warnings survive in mythic tales of falling stars, or were their observatories the first to crumble under the onslaught? The cosmos, after all, plays no favorites, turning thriving worlds into barren craters in an instant. Shifting to subtler threats, magnetic field reversals present a stealthy peril, where the planet's protective shield flips, exposing life to solar radiation's harsh barrage. During these flips, cosmic rays penetrate deeper, mutating DNA and disrupting navigation in migratory species. For a civilization reliant on electromagnetic tech, perhaps early compasses or bioelectric signaling, a reversal could sow chaos, frying circuits or inducing widespread genetic disorders. Paleomagnetic records show these events recurring irregularly, with weakened fields lasting centuries. Imagine a society mid-boom, their innovations halted by auroras gone wild and communication blackouts, leading to societal fracture. The curious builds. Could lingering radiation explain unexplained extinction pulses, or did such an event force a retreat underground, their surface legacy scoured by intensified erosion? This invisible assassin highlights intelligence's vulnerability to forces beyond control, a reminder that even the stars can conspire against progress. Now, turn the lens inward to self-inflicted wounds, where ambition becomes the architect of downfall. Overexploitation of resources looms large. A civilization mining rare minerals or deforesting vast swaths for fuel, only to trigger soil depletion and biodiversity crashes. Picture aquifers drained dry, leading to salinized farmlands and famine, or overfished oceans collapsing food chains. In our era, we see parallels in collapsing fisheries and desertification, but scale it back to a pre-industrial analog. A society harnessing biomass on a continental scale, their emissions subtly warming climates until monsoons fail and dust bowls engulf cities. The curiosity peaks with feedback loops. Did their tech accelerate tipping points, like methane releases from thawing permafrost, amplifying a slow burn into rapid collapse? This narrative weaves tragedy with irony, intelligent beings engineering their own obsolescence through unchecked growth. War and conflict add a human, all too human dimension, even if the actors weren't humanoid. Envision rival factions clashing over dwindling resources, their weapons escalating from primitive tools to devastating energies. Biological agents released in desperation could mutate beyond control, sweeping through populations like wildfires. Or perhaps nuclear equivalents, harnessing fission from natural uranium deposits, leaving radioactive hotspots that linger as geologic anomalies. The Permian mercury spikes, often tied to volcanism, could hint at such fallout, toxic plumes from ancient arsenals poisoning air and water. What keeps this engaging is the psychological depth. Did ideological rifts fracture unity, or did scarcity breed paranoia? Intelligence, after all, brings not just innovation but division, where the same minds that build empires can devise their destruction. Pandemics offer a chilling vector, microbes evolving alongside hosts until a leap sparks global contagion. For an ancient society, close-knit communities or global trade could accelerate spread, their healers overwhelmed by symptoms defying cures. Genetic bottlenecks in fossil populations suggest such culls, where diversity plummets post-event. Imagine bioengineered pathogens escaping labs, or zoonotic jumps from domesticated species scenarios mirroring our modern fears. The curious intensifies. Could preserved viral DNA in ice cores trace back to artificial origins? Or did natural reservoirs like permafrost harbor doomsday bugs? This self-sabotage underscores evolution's irony, where cleverness invites microscopic nemesis. Yet, not all ends are tragic. Some might stem from choice, a deliberate fade into harmony. Picture a civilization achieving enlightenment, recognizing dominance's toll and opting for dissolution, dismantling structures, reverting to nomadic ways, or integrating so seamlessly with nature that traces vanish. This voluntary vanishing could arise from ethical awakenings, viewing permanence as hubris. In fungal networks or hive minds, dissolution might be cyclical, intelligences dispersing to seed new forms. The allure lies in this grace. Did they encode knowledge in genes, passing wisdom through evolution, or retreat to hidden enclaves, observing from shadows? Mythic tales of ascended beings echo this. Societies choosing transcendence over legacy. Environmental tipping points blend natural and self-induced, where subtle shifts cascade into uninhabitability. A society geoengineering climates might overshoot, freezing or scorching their world. Or resource wars escalate to ecological suicide, salting Earth in victory's name. The Devonian anoxic events, darkening oceans, could reflect such overreach. Algae blooms from nutrient runoff suffocating seas. Cosmic rays or solar flares add extraterrestrial peril, intensified during magnetic lulls, frying biology and tech. A gamma-ray burst from a distant supernova could sterilize half the planet, its radiation pulse invisible yet lethal. For ocean dwellers, this might mean extinction, their watery realms no shield. In fertility crises, intelligence might curb reproduction through cultural shifts or tech, populations dwindling gracefully. Or arrogance leads to genetic tinkering gone wrong, sterility spreading like a silent plague. The narrative's richness stems from these intersections: catastrophe meeting choice, nature entwining with nurture. Each possibility mirrors our dilemmas, from climate brinkmanship to ethical AI. If they chose fade, perhaps for balance. If self-destructed, a warning against excess. Whispers from the ancients drift through the mists of time, carried on the winds of forgotten dreams, where gods walked among mortals and entire worlds rose and fell in cycles of creation and ruin. These are the myths, not mere fables spun around campfires, but perhaps fragmented echoes of realities long dissolved into the ether, collective memories twisted by generations, reshaped by fear, wonder, and the inexorable pull of oblivion. What if the tales of sunken continents and golden ages aren't inventions of the imagination, but distorted recollections of civilizations that predated our own, their stories surviving as archetypes in the human psyche? Dive into this labyrinth of lore, where Atlantis beckons from the depths, Yugas unfold in eternal wheels, and each legend hides a kernel of truth, inviting us to question whether history's veil conceals not just events, but entire epochs of intelligent life now lost to the shadows. Atlantis stands as the archetype of the vanished paradise, a gleaming metropolis of advanced wonders that plunged beneath the waves in a single cataclysmic night. In the dialogues of an ancient Greek philosopher, it's described as a naval powerhouse beyond the Pillars of Hercules, its people blessed with knowledge of metallurgy, architecture, and governance far surpassing their contemporaries. But arrogance corrupted them, leading to divine wrath that swallowed their island whole. Was this a moral allegory for hubris, or a garbled transmission of a real disaster? Explorers in the mid-20th century scoured the Atlantic for traces, unearthing underwater formations off Bimini that some claimed were road remnants, though geologists dismissed them as natural beach rock. The allure persists. What if Atlantis was no myth, but a memory of a pre-flood society, their tech canals for irrigation, concentric rings for defense echoing engineering feats that hint at forgotten expertise? The ocean's depths, vast and unexplored, could cradle their ruins, pressure-crushed and sediment-shrouded, waiting for submersibles to pierce the gloom and reveal whether this lost realm was earthborn or something more ethereal. Venturing eastward, the Hindu Yugas paint a cosmic drama of recurring ages, each a descending spiral from purity to decay. The Satya Yuga gleams as a golden era of truth and virtue, where beings lived for millennia in harmony with Dharma, their lifespans dwarfing ours. As cycles turn, Treta brings silver virtues tinged with vice, Dvapara introduces bronze imbalances, and Kali, the Iron Age we inhabit, ushers in strife, shortened lives, and moral eclipse. Epics like the Mahabharata weave tales of flying chariots, divine weapons that scorch the earth, and sages wielding powers akin to modern science. Could these be veiled accounts of technological marvels from prior civilizations, their gods actually advanced ancestors whose knowledge survived as oral traditions? The Yugas' cyclical nature fascinates, suggesting history isn't linear but looped, with resets, pralayas wiping slates clean through floods or fires. Imagine a society at Dvapara's cusp, harnessing energy fields or genetic arts, only for cosmic realignment to trigger their fall, their wisdom encoded in Vedic hymns as riddles for future seekers. The Mayan calendar wheels echo this rhythm, dividing time into suns worlds created and destroyed in succession. The current fifth sun follows four predecessors. One ended in jaguar attacks, another in hurricanes, a third in fire rain, the fourth in floods. Each era birthed different peoples, their fates sealed by divine displeasure or natural fury. Codices depict feathered serpents and star gods guiding humanity, their prophecies aligning with celestial events like Venus transits. What captivates is the precision. Mayan astronomers tracked cycles with observatories, their zero-based math rivaling later innovations. Might these suns memorialize real collapses, volcanic winters, or sea-level surges that erased prior intelligences? Ruins like Palenque, with pyramid alignments to solstices, suggest astronomical savvy that could stem from inherited lore, survivors of earlier suns embedding warnings in stone. The curious swells. If the fifth sun ends in earthquakes as prophesied, are we replaying an ancient script, our tech unwittingly accelerating the cycle? Sumerian epics add ancient voices, their clay tablets recounting kings who reigned for tens of thousands of years before a deluge reset civilization. The Eridu Genesis lists rulers like Alulim, whose dominion stretched impossibly long, perhaps symbolizing epochs rather than individuals. Then came the flood, sent by gods weary of human clamor, sparing only a pious survivor to rebuild. The Epic of Gilgamesh mirrors this, with its hero seeking immortality amid ruins of antediluvian wisdom. Cuneiform inscriptions describe ziggurats reaching heavens, flying boats, and battles with monstrous guardians elements that evoke advanced tech or genetic hybrids. Could these be echoes of a Mesopotamian precursor society, their gods Enki and Inanna representing elite engineers or biomanipulators? Archaeological digs in the Fertile Crescent uncover irrigation networks and urban grids predating known settlements, hinting at organized intellects whose fall, perhaps drought-induced, scattered knowledge into mythic fragments. African lore contributes enigmatic threads, with Dogon tribes recounting Sirius star knowledge that predates telescopes, They're myths of fish-like Nommo descending from the sky to impart civilization. Rituals align with Sirius's helical rising, tied to 50-year cycles mirroring the star's companion orbit information modern astronomy confirmed in the mid-19th century. Skeptics cite cultural contamination from early explorers, but the precision intrigues. What if Nommo symbolize aquatic ancestors, an intelligence from ancient lakes, whose astronomical insights survived oral chains? Similarly, Zulu tales of sky people and creation from reeds evoke bioengineering, their chieftains wielding thundersticks akin to energy weapons. Polynesian voyages weave oceanic mysteries, with legends of Mu, a vast Pacific continent that sank, its people navigating by stars to new islands. Oral histories describe tattooed maps and wayfinding canoes, skills allowing transoceanic treks without instruments. Bathymetric surveys reveal submerged plateaus like the Ontong Java, fueling speculation of lost landmasses. The curiosity ignites. Did Mu's inhabitants master celestial navigation and sustainable seafaring? Their downfall a mega, tsunami or volcanic chain reaction, leaving migratory myths as their legacy. Native American narratives enrich the mosaic, with Hopi Kachinas emerging from underworlds through Sipapas, guiding clans across landscapes. Their emergence myths cycle through worlds destroyed by fire, flood, and ice, survivors ascending to new realms. Kiva ceremonies reenact these, with sand paintings mapping cosmic orders. What if these underworlds symbolize bunkers from ancient cataclysms, Kachinas as suited figures from a tech-savvy past? Petroglyphs in Chaco Canyon align with solstices, suggesting observatories for predictive astronomy. Egyptian lore whispers of Zep Tepi, the first time when gods ruled from Heliopolis, teaching arts before handing reins to pharaohs. The Osiris myth dismemberment and resurrection could encode genetic revival or cloning, their pyramids as energy conduits. Turin Papyrus lists divine kings with reigns spanning millennia, perhaps compressed eras of advancement. Chinese legends of Fu Xi and Nua, serpent-tailed creators mending the sky after a pillar collapsed, evoke cosmic repairs post-disaster. Their invention of writing and calendars hints at inherited tech, the Yellow Emperor's flying chariots suggesting aerial prowess. Norse Ragnarok foretells worlds ending in battle and flood, survivors birthing anew. Yggdrasil's tree connects realms, perhaps metaphor for genetic trees linking epochs. These myths converge in flood motifs, universal deluges purging corruption, from Noah's Ark to Deucalion's survival. Plato's Atlantis ties to this, perhaps echoing Mediterranean Bronze Age collapses like the Santorini eruption. The shared archetypes fascinate. Do they stem from collective unconscious, or real megafloods from ice melt? The Yugas' dissolution through pralaya mirrors Mayan sun's ends, suggesting global memory of cyclic resets, perhaps comet swarms or solar flares. Atlantis's hubris parallels Kali's decay, moral lessons veiling historical falls. Intriguingly, quantum entanglement theories posit myths as non-local memories, archetypes resonating across time. Psychedelic visions in shamanic rites often replay these golden ages, serpentine teachers hinting at altered states, accessing ancestral data. Recent genetic studies trace human bottlenecks, survivors of near extinctions carrying oral epics as survival manuals. Indigenous knowledge preserves star maps and migration routes, perhaps fragments from deeper pasts. As these tales weave through the quiet of the night, I wonder, where are you joining me from right now? Maybe a cozy cabin in the Rockies, a seaside balcony in Santorini, or a city apartment aglow with neon. What's the clock showing there? As we chase these ancient whispers together, the enigma endures. If myths are memories, what intelligences birthed them? Each tale a breadcrumb, leading through time's maze to truths that shimmer just beyond reach, keeping the soul alight with eternal questioning. In the flickering glow of computer screens deep within research labs, where algorithms hum like digital detectives sifting through the sands of time, the hunt for spectral remnants of lost civilizations has evolved into a high-tech thriller. No longer confined to dusty digs with brushes and trowels, modern seekers employ artificial intelligence as their tireless ally, scanning vast datasets for anomalies that could unmask intelligences from the planet's shadowy past. Picture neural networks trained on satellite imagery, their electronic eyes piercing forest canopies or desert dunes to reveal hidden structures, patterns too subtle for human vision, yet screaming of deliberate design. This is the new frontier of ghost hunting in archaeology, where AI doesn't just assist, it anticipates, predicts, and sometimes even outsmarts the researchers, turning whispers from the earth into resounding revelations that challenge our grasp on history. The adventure kicks off with predictive modeling, where AI devours environmental data, historical patterns, and geophysical scans to forecast where ancient secrets might lie buried. Instead of random excavations that could take lifetimes, these systems highlight hotspots with eerie accuracy, guiding teams to sites brimming with potential. For instance, in urban sprawls where modern cities overlay ancient grounds, AI tools like Urban Analyzer revolutionize the process by analyzing soil types, water proximity, and past finds to pinpoint artifact-rich zones. This not only boosts discovery rates but slashes the chaos of digging in bustling areas, preserving history without halting progress. The thrill intensifies as you realize these models learn from each success, refining their hunches like a seasoned explorer, honing instincts over countless quests. What hidden metropolis or forgotten forge might they uncover next, perhaps one predating known timelines by eons? Satellite and drone imagery form the backbone of this digital pursuit, with AI algorithms combing pixels for irregularities that betray human or perhaps pre-human intervention. In the Peruvian desert, where the Nazca lines have long puzzled with their massive geoglyphs, AI has recently doubled the known count by spotting over 300 new figures in mere months, a feat that would have demanded years of footwork. These humanoid and animal motifs, etched into the arid canvas, align with celestial events, sparking debates. Were they ritual markers or signals from a society attuned to the stars? The AI's machine learning sifts through terabytes of high-res data, flagging shapes invisible from ground level, then verified by boots on the ground teams. This synergy keeps the narrative pulsing, each new glyph a puzzle piece, potentially linking to astronomical calendars or even communication arrays from a vanished era. Imagine if similar tech scanned the Sahara or Amazon, unveiling submerged networks or overgrown observatories that rewrite our evolutionary saga. LiDAR technology amps up the excitement, firing laser pulses from aircraft to map terrain beneath vegetation, stripping away foliage to expose bare earth contours. In dense jungles like those cloaking Mayan ruins, LiDAR has unveiled sprawling urban complexes complete with roads, pyramids, and reservoirs, suggesting populations far larger than imagined. The curiosity surges. If LiDAR can resurrect these ghost cities from the Green Veil, what might it reveal in older strata, perhaps Precambrian anomalies hinting at non-human builders? Ground-penetrating radar complements this, sending electromagnetic waves into soil to detect buried voids or artifacts without a single shovel strike. In European fields, it has mapped Roman villas and Celtic hill forts, their layouts pristine in subsurface echoes. Applied to deeper mysteries, like anomalous metallic deposits in ancient rock, it could flag engineered chambers or tool caches, turning speculation into tangible targets. Artificial intelligence's role in artifact reconstruction adds a layer of wizardry, where fragmented relics are digitally reassembled with precision that borders on the magical. Shattered pottery or frescoes from volcanic burials, like those in Pompeii, feed into generative algorithms that predict missing pieces based on patterns and historical contexts. The Repair project exemplifies this, piecing together thousands of fresco shards through adversarial networks that simulate and refine restorations. The wonder here is palpable. What if such tech revived artifacts from deeper antiquity, like enigmatic spheres from South African mines, revealing internal mechanisms or inscriptions that speak of lost tech? This not only accelerates discoveries, but breathes life into relics, allowing virtual manipulations that preserve originals while unlocking their stories. The plot thickens with AI's foray into historical simulations, where models recreate evolutionary paths or societal dynamics from sparse data. By inputting fossil distributions and environmental variables, These systems forecast how intelligences might have emerged and adapted, perhaps simulating cephalopod societies in ancient seas or avian flocks with tool-sharing behaviors. In game-like environments, AI tests hypotheses. How would a fungal intelligence respond to climate shifts, or a swarm mind navigate extinctions? This virtual archaeology keeps the engagement high, offering what-if scenarios that bridge gaps in the record, like unexplained biodiversity jumps that could stem from bioengineered interventions. Ice cores and sediment archives become treasure vaults under AI scrutiny, their layered contents passed for chemical oddities. Machine learning algorithms detect isotope anomalies or pollen shifts that might signal artificial disruptions, sudden carbon influxes from ancient industry, or trace metals from mining ops. In Antarctic drills, cores spanning hundreds of thousands of cycles reveal atmospheric snapshots, with AI flagging deviations that align with hypothermal events. The curious builds as patterns emerge, a spike in rare earth elements coinciding with extinction horizons, perhaps from tech waste, or nitrogen enrichments hinting at large-scale agriculture. These digital sleuths process vast cores in hours, cross-referencing with global databases to spot correlations that human eyes might miss. Bioinformatics joins the fray, sequencing ancient DNA from permafrost or cave sediments to trace lineages back through resets. AI clusters, genetic markers, identifying bottlenecks or hybridizations that suggest guided evolution, perhaps ancient gene editing to adapt to changing climes. In Siberian thaws, mammoth tusks yield viral genomes, their sequences analyzed for artificial tampering. This genetic detective work fascinates, potentially linking modern traits to forgotten experiments, like enhanced cognition in corvids tracing to prehistoric boosts. Space-based tools elevate the search, with telescopes and probes scanning exoplanets for technosignatures, atmospheric pollutants, or megastructures that mirror what we seek on Earth. This cosmic parallel intrigues. If we hunt for alien sieves through spectral lines, why not apply similar filters to our geologic spectra? AI processes these signals, modeling how a Silurian-era society might appear in infrared or radio echoes, perhaps faint heat anomalies from buried reactors. Underwater robotics extend the quest to abyssal plains, where autonomous vehicles map seamounts for submerged anomalies, sunken plateaus that could be eroded remnants of ancient landmasses. AI steers these bots, analyzing sonar for artificial geometries amid natural chaos. In Pacific trenches, they've charted hydrothermal fields teeming with life, their ecosystems passed for biosignals of engineered origins. The narrative pulses with ethical quandaries. As AI uncovers sites, how do we balance revelation with preservation? Indigenous knowledge integrates here, AI cross-referencing oral histories with geospatial data to honor cultural contexts. This holistic approach keeps the story dynamic, blending tech with tradition. Quantum computing looms on the horizon, promising to crunch petabytes of archaeological data, simulating molecular decays or evolutionary branches with fidelity that unmasks hidden patterns. In labs, prototypes already tackle protein folding for ancient biomolecules, potentially decoding extinct languages from phonetic echoes in artifacts. Crowdsourced platforms democratize the hunt, where citizen scientists feed AI with photos of odd finds, algorithms classifying them against vast libraries. This global net casts wide, unearthing backyard anomalies that compile into broader mosaics, perhaps a network of aligned stones hinting at astronomical grids from lost eras. The excitement crescendos with augmented reality overlays, where apps superimpose reconstructions on real sites, letting users see vanished structures. This immersive tool educates while engaging, turning passive viewers into active explorers. In this AI-augmented odyssey, the search for phantoms becomes a symphony of silicon and curiosity, each discovery a note resonating through time. From Nazca's newfound glyphs to simulated evolutions, the tools peel back layers, revealing that the past's shadows might hold mirrors to our future. As algorithms evolve, so does our grasp on the enigmatic, keeping the pursuit eternally alive with promise and peril. As the veil of night draws close, wrapping the world in its quiet embrace, Let us pause to reflect on the fragile tapestry we weave across this ancient planet, a legacy not carved in stone, but etched in the very air we breathe, the soil we tread, and the choices we make under the stars. What will remain of us when the echoes of our voices fade, when our towering achievements crumble into dust, and future wanderers sift through the remnants of our time? This is the profound mystery of our inheritance, a story not of conquest, but of quiet warnings whispered from the ruins of those who came before. In the hush of this moment, as sleep beckons with its gentle pull, imagine standing at the crossroads of history, where the lessons of vanished worlds illuminate the path ahead, urging us to craft a heritage that endures not through dominance, but through harmony with the eternal rhythms of existence. Our legacy begins with the indelible marks we leave on the Earth's canvas, those subtle signatures that geologists call Anthropocene, indicators traces of a species that bent the planet to its will. Consider the plutonium veil that encircled the globe after the dawn of nuclear testing, a thin radioactive shroud now embedded in sediments worldwide, serving as a potential golden spike for our era. Recent proposals suggest pinpointing the Anthropocene's onset to moments when human actions first altered global methane levels, a shift that mirrors how our agricultural revolutions and industrial pursuits have reshaped atmospheric chemistry. These markers aren't mere footnotes, they are harbingers, reminding us that every emission, every extraction weaves into the geological narrative. What curiosity arises when we ponder, will future eyes view our carbon footprints as monuments to innovation, or as scars of short-sightedness? The planet, ever the patient scribe, records it all: ocean acidification from our excesses, biodiversity plummets from habitat fragmentation, crafting a story that could outlast our species by eons. Yet, in this tale of imprinting, artificial intelligence emerges as both a tool and a teacher, guiding us toward a more sustainable inscription. Picture AI systems optimizing vast farmlands, predicting crop yields with uncanny precision to minimize water waste and fertilizer runoff, or monitoring urban sprawls to reduce energy consumption in real time. In the realm of biodiversity, algorithms now track endangered species through satellite eyes, fostering conservation corridors that heal fragmented ecosystems. The intrigue deepens with AI's dual nature, its voracious appetite for energy and water, powering data centers that rival small cities in consumption, juxtaposed against its potential to accelerate green innovations like efficient solar grids or carbon capture tech. As we stand on this threshold, the question lingers: can we harness this digital ally to rewrite our legacy, ensuring it speaks of wisdom rather than waste? Lessons from past societies, where over-reliance on finite resources led to downfall, echo here. Think of irrigation networks that salinized fertile valleys, or deforestation that eroded once thriving soils. In our age, AI offers a chance to learn, modeling scenarios where sustainability triumphs, turning potential collapse into renewal. The ghosts of ancient civilizations hover close. There falls a mosaic of insights that tantalize with relevance. From the verdant realms of the Maya, where intensive farming and urban expansion strained water supplies until droughts delivered the final blow, we glean the peril of ignoring environmental limits. Their stepped pyramids and intricate calendars stand as silent sentinels, whispering of a people who charted the stars, yet failed to foresee the ground shifting beneath them. Similarly, the Roman expanse, with its aqueducts, channeling life to bustling metropolises, crumbled under the weight of overextension, soil exhaustion from relentless agriculture, lead poisoning from plumbing innovations, and climatic shifts that amplified vulnerabilities. What keeps the mind engaged is the pattern. Societies often grow fragile with age, their complexities breeding inefficiencies, much like how modern global supply chains teeter on the edge of disruption. Recent analyses draw parallels, noting how pre-modern states became prone to unraveling as internal stresses mounted, a fragility that holds mirrors to our interconnected world today. Delving into these echoes, the concept of self-termination surfaces as a haunting possibility, where civilizations sow the seeds of their own end through inequality and unchecked growth. Epoch studies spanning 5 millennia reveal that societal collapses often stem from elite overconsumption, widening gaps that erode resilience. Floods of refugees, resource wars, and institutional decay follow, culminating in resets that pave the way for rebirth, but at what cost? The curiosity spikes when we consider biocultural adaptations. Some groups, like the resilient Polynesians navigating vast oceans with star-guided canoes, embedded sustainability in their lore, ensuring survival through adaptive taboos on overharvesting. Contrast this with the Easter Islanders, whose statue-building fervor led to deforestation and societal implosion, a stark lesson in ecological overreach. In our narrative, these tales urge introspection. Will our digital divides and resource hoarding script a similar finale? Or can we pivot toward equity, drawing from indigenous wisdom that views the land not as commodity, but as kin? The intrigue heightens with visions of rebirth, where collapsed worlds fertilize new beginnings. After the Bronze Age unraveling, where trade networks frayed amid invasions and droughts, emergent societies like the Phoenicians innovated alphabets and seafaring, turning ashes into advancement. This cyclical resilience captivates. Destruction often clears paths for innovation, much as volcanic soils nurture lush regrowth. Applying this to our horizon, AI-driven simulations forecast how current crises, climate migrations, or resource scarcities might forge adaptive futures, perhaps decentralized communities harnessing renewable energies. The question dangles: if we heed these historical rhythms, can our legacy be one of transformation, not termination? Sustainability threads through these lessons like a hidden current, where ancient practices offer blueprints for endurance. In arid realms, terraced farming and qanat systems, underground channels tapping aquifers, sustained populations for centuries, balancing human needs with nature's bounds. The Inca's Andean storehouses, stockpiling against lean times, exemplify foresight that buffered against El Niño whims. Yet, when harmony fractured, as in Mesopotamian salinization from over-irrigation, downfall followed. Today, these insights inspire AI optimizes similar systems, predicting droughts to guide water allocation, echoing ancestral prudence in silicon form. The curious builds: what untapped wisdom lies in untranslated scrolls or oral traditions waiting to inform our green revolutions? Conspiracy undercurrents add spice, with whispers of elites orchestrating resets to maintain power, hoarding knowledge while societies crumble. Tales of hidden bunkers or suppressed tech evoke dystopian chills. But balance tempers, this true resets often arise from systemic flaws, not cabals. Historical parallels, like Roman senatorial greed exacerbating famines, warn against complacency, urging collective vigilance. As sleep's gentle tide rises, these reflections coalesce into a call for mindful legacy building. Our marks, Anthropocene scars, or sustainable symphonies will define how future voices narrate us. Will they speak of a species that learned from phantoms of the past, weaving AI with ancient lore to foster balance? Or of one that repeated errors, fading into geologic footnotes? In this nocturnal contemplation, the mystery endures, a lullaby of possibilities that invites dreams of wiser tomorrows, where our heritage shines not as dominion, but as enduring light in the cosmic dark.